Okay, let's continue on with example 2. In example 2, we were given two similar triangles. We're told that they're similar, and we're given the fact that they have 47 degrees on the bottom left and 98 degrees on the top. And the smaller one has sides 3, 4, and 6, and the larger one has A and B and 16. And we're told to find A and B. Well, we can use the fact that we know these are similar, and that similar triangles have proportional sides to set up our solution. So if I look at the corresponding sides here, I'll just write them out. I'll put the TU should be corresponding to WX. You see that? TU and WX are corresponding sides. And they should set up a proportional ratio UV to XY. And that should also, the bottom should also come across TV to WY. So those three fractions should all equal each other. And let's now substitute in the actual values. TU is 3 over A. UV is 4. And XY is 16. TV is 6 over WY, which is B. So we're looking for A and B. So we can set this up as two separate problems. The first problem, we'll set up a proportion. 3A equals 4 over 16. We cross multiply, we get A4 is equal to 48. Divide both sides by 4, and we're left with A is equal to 12. So we've just solved for A. Now we can do the same thing using that proportion. We'll do that right here. 4 over 16 is equal to 6 over B. Cross multiply, we get 96 going this way, and coming back this way we get 4B. Divide by 4, and B is equal to 24. And so the two missing parts of this triangle, A and B, are 12 and 24. Okay, let's look at example 2B in your book. In 2B, we have this triangle. And this is kind of a triangle drawing that you'll see a lot in the books. It's one triangle with a small triangle inside of it. Okay? And we'll call this A, B, C, D, and E. And we know that these are both right angles. Okay? And we know that from here to here is 6 long, and from here to here is 9. We know that we want to find X, that outside, and we're given that this is 10, the inside vertical line. Okay, so we're told from this problem, find X. Okay. And one of the things we're given is that triangle ABE is similar to triangle ACD. So this little one is similar to the big one. And right away we're looking for a side, and since we know they're similar, we can set up a proportion. We know that X over 10, which is the big triangle over the little triangle, is got to be equal to the same proportion as these two bottom numbers. So the big one is 9 over 6. We cross multiply, get 90 equals 6x. Divide both by 6, and we get x equals 15. So we've just solved for x. What would happen if I had done that differently? Let's say I had decided to do the small triangle on the top, and I had said 10 over x. Well, because I did the small triangle on the top, then I have to do the small triangle on the second proportion. So the proportion would be 6 over 9, and you notice you get 6x equals 90 again, and x still equals 15. So as long as you don't mix which order you're doing it, the proportion you set up can be in either format, either big over little or little over big. Okay, as long as you don't mix them up. And finally, let's take a look at a kind of a real-world problem. Let's take a look at a problem where we have Janelle and the Washington Monument. Okay, and Janelle is standing on the sidewalk next to the Washington Monument, and the shadow, she's casting a shadow right here. Okay, and her shadow is 3 feet long, and we know that Janelle is 5.5 feet tall. She's standing next to the Washington Monument. There's the Washington Monument, and it is casting a shadow right there, and its shadow is 302.5 feet long. How tall is the Washington Monument? Well, we know that because everything's happening at the same time, these are similar triangles. So we can set up our proportion. We know that Janelle, 5.5 feet over her corresponding side is x on the Washington Monument. And here, we'll say 3 is her shadow, and the shadow of the Washington Monument is 302.5. Okay, so now what we'll do is cross multiply. We cross this way, we get 3x. And you multiply that times that, you get 166.3.75. Divide both sides by 3, and you get 554.6 feet. And this is not equal, it's approximate. And there we've solved how tall the Washington Monument is by using Janelle's shadow on the sidewalk and measuring the shadow of the Washington Monument.